Welcome back to Math with Ms. Reimer. Today we're looking at lines and the vocabulary that goes with it. This sheet will really serve as a great reference for you with all of this vocabulary. Complementary angles are 90-degree angles. So these two are 90 degrees total because of the right angle mark in the corner. And if I know the angle ABD, which is this one, ABD, is right here, is 61 degrees, then I know the angle DBC is going to be 90 minus 61, and then that will give me my answer. My answer ends up to be 29 degrees when I do my subtraction. Supplementary angles are 180 degrees. You can remember this because supplementary has two p's, whereas complementary only has one. So the 1p is a smaller measure, the two p's are the larger measure. So they're 180 degrees total. And if EFH, which is EFH here, is 133 degrees, then I can figure out that HFG is 180 minus 133. So this ends up being 47 degrees total. Vertical angles are opposite angles. So they're angles that are across from each other, and they have the same measurement. So that means B and D are the same, A and C are the same as well. Something I want you to notice is that the next door neighbor angles here are supplementary. A and B make a straight line together, so they're 180 degrees. Same thing in this diagram, 1 and 3 are across from each other, 2 and 4, and so they share the same measurement as we go. If you have a set of parallel lines and it's cut by a transversal, the transversal here would be L, here it would also be L. It's the line that cuts the parallel lines. You end up with interior angles, which are inside the parallel lines, and exterior angles, which are outside the parallel lines. You can have same-side interior angles, like 4 and 6, or same-side exteriors, like 1 and 7. Remember that parallel lines, this double line is the notation for parallel, so this states that M is parallel to line N, and that L is the transversal. Also having to do with interior and exterior angles, we have alternate interiors, which are on opposite sides of the transversal inside the parallel lines, like 3 and 6, or 4 and 5. Over here, we have B and F and C and G. They're always in between the parallel lines, regardless of how the set is oriented. Alternate exteriors are opposite outside angles. So they're on opposite sides of the transversal, but outside of the parallel lines. So like 1 and 7 and 4 and 6, or A and H and D and E. You'll notice that depending on what angle the transversal hits and how the parallel lines are adjusted, depends on where it looks like when you actually find these angles. One last set of vocabulary here are corresponding angles. Corresponding angles have the same position, the same measure, and they mock each other. So 1 and 5, you can see in their little groups of 4, 1 and 5 are both in the upper left-hand corner. So 1 and 5 are corresponding, and they have the same measurement. Same with 2 and 6, 3 and 7, 4 and 8. Same thing if I rotate my sets of parallel lines, still look at the groups of 4, and then they have to be in the same position in the groups of 4. One thing that's true about alternate interior, alternate exterior, as well as corresponding angles is all of those pairs share the same measurement. Now, because of these definitions, I can do some math to figure out the angles of the measurement of all of the angles here. In a set of parallel lines crossed by a transversal, you have two different angle measurements. So we start by knowing that angle 1 is 39 degrees. Now, because I know angle 1 is 39 degrees, I also know that angle 2 is 39 degrees because it's a vertical angle. If I know angle 2 is 39, angle 7 corresponds to that one, and so that has to be 39 degrees also. And then across from angle 7 is angle 8. Those two are vertical, so that one's also 39 degrees. Notice that there's 4 of them with the same measurement. To find the other angle that I'm missing, the 3, 4, 5, and 6, I can notice here that angle 1 and angle 4 are supplementary to each other. It means that they equal 180 degrees total. So if I do 180 minus 39, then I will end up with my answer, which is 141 degrees. So 141 is angle 4, and if that's angle 4, angle 3 is vertical to that, so that's also 141. Angle 5 is alternate interiors to that, or corresponding to 6, either way. And so both of those are 141 degrees also. The same thing applies over in example 2. If I know that A is 112 degrees, then I know C is 112 because they're vertical. I know A and G are alternate exterior angles, so that's 112. And C and E are alternate interiors. Now you'll notice there is multiple reasons that I can say for why these angles are that measure. A and E are alternate interiors. C and E are alternate interiors. These two are vertical. These two are vertical. I've got corresponding angles. You can see that all of those definitions really overlap each other but they all prove that the angles are congruent. To find B, D, F, and H, I can notice that A and B are supplement to each other, meaning that they equal 180 degrees total. And so I can take 180 degrees minus 112, and that will leave me with 68 degrees. And if B is 68, D is vertical to that, F is alternate interior to that, and H is vertical to that also. Notice they kind of make Z's, or they like crisscross their way across the sets of parallel lines, the angles that are the same. When we get to example 3, we're going to list off a whole bunch of names of angles or types of angles, classifications. So for instance, in example 3, if I need vertical angles, then I'm going to look for the 4 pairs of vertical angles in example 3. Well, verticals are across from each other. So if I start at 1, it's vertical to 3, 2 is vertical to 4, 5 to 7, and 6 to 8. So those are the across from angles. Corresponding angles have the same position. So if I start at 1, that's in the upper left-hand position. Go down to here, 5 is in the same position, upper left hand. So 1 and 5. 2 and 6 hold the same position of upper right. 4 and 8 are lower left. And 3 and 7 are lower right. All of the interior angles and exterior angles, the interiors would be 4, 3, 5, and 6, and the exteriors are 1, 2, 8, and 7. Alternate interior and alternate exterior. Alternate exteriors would be outside the parallel lines and on opposite sides of the transversal, so that would be 1 and 7, and 2 and 8. Alternate interiors are inside the parallel lines, but on opposite sides of the transversal, so that would be 3 and 5, and 4 and 6. Supplementary angles, there are a ton of supplementary angles in here. I only need 4 pairs. So I just need 2 angles that will line up to make a straight line. So I could use 1 and 2. I could use 5 and 8, make a straight line together. I could use 6 and 5. I could also use 6 and 1, because 6 and 1, though they're not right next to each other, they will equal 180 degrees because these 4 angles share the same measure, and then the other 4 share the same measure as well. And so 6 is supplement to 5, and 1 is complement to 5. So 1 and 5 have the same measurement. And lastly, we're going to find a whole slew of angles in examples 4 and 5 just by knowing a couple measurements right off the bat. So I know angle 1 is 70 degrees. And if I know angle 1 is 70, then I know that 3 is vertical to that. So I can go ahead and note that 3 is 70 degrees also. I know that 4 is supplement to 1. So I know that I can do 180 minus 70, and that will give me 110. Both 2 and 4 are 110 because they're vertical to each other. Now, if I keep going, I know that 14 here is going to be 90 degrees because of this marker right here. So I can go ahead and jot that down. And I know that this triangle here in the middle, I know that triangles have 180 degrees, which means that 180 minus 90 minus 70 leaves angle 12 to be 20 degrees. 13 is vertical to 12, so 13 is 20 also. And then 11 is supplement to 13, so that's 180 minus 20, which is 160. Angle 8 is vertical to angle 11, so we get 160 for both of those. Now let's see what else we can do here. Down here at the bottom, 14 is vertical to angle 9, and so that means angle 9 has to be 90 degrees also. Then if we look at some of our z's or zigzags that go back and forth, 1 and 3, if we pay attention to just this transversal and this set of parallel lines, 1 and 3, then 5 is also going to be a part of that. So 3 and 5 are alternate interiors. So 5 is 70 degrees. If I know 5 is 70, I know 6 is 70 because they're vertical. And then the other part of my z comes in over here. But when I look at that, the part that is 70 is going to be right here. So when we look at 7 and 10, one of the things I can do is I can go, okay, these 3 angles make a supplementary line. So if these 3 angles have to equal 180 degrees, well, 180 minus 70 minus 90 leaves 20 degrees. And then angle 7 is vertical to angle 10. In example 5, we've got 2 triangles here, but still 2 transversals going through one set of parallel lines. So we know that angle 2 is 110 degrees, so let's start there. And I know angle 11 is 138. So let's start with our vertical buddies. So 13 is vertical to 110, and 9 is vertical to 11. I know that 1 and 2 have to be supplement together, so they equal 180 degrees together. So minus 110 from 180 will give you 70 for angle 1. And so that means that this piece right here is 70 degrees also. And angle 13 is 110 degrees also, which actually I already had figured out from somewhere else. Over here, angle 9, this one's 138, and I know that 11 and 12 have to supplement to each other. They're 180 degrees. So if I subtract 138 from 180, I will get 42 degrees for 12. And 10 is vertical to that, so 10 has to be 42 degrees also. Now, if I do some zigzagging here, we'll go from 11 to 9. If I only pay attention to this transversal, 11 to 9, and then 3 and 5 are also 138. 138 is corresponding to angle 3. 3 and 11 are corresponding. 9 and 3 are alternate interiors. And so we'll get 138 here. I know that 3 and 4 have to be supplement to each other, so that will make 4 42 degrees. And then I can do some zigzagging over here as well, and I can go from 1 to here to over here down to here in 7. So 7 is also 70 degrees. It is alternate exterior with angle 1. And then 6 and 8 have to be supplement to that. So this is 180 total. So that means 6 has to be 110. And 8 is vertical to 6. So that one is 110 also. That's all today for Math with Miss Reimer. Remember the 5 things. You are lovable, valuable, changeable, forgivable, and never alone. I hope you're confident in the math. I hope you feel like you know what you're doing more than anything else. I hope you know that I care. Bye.